Hello and welcome to the webinar. My name is Neil Cook from Onshape, and today we're going to be talking or showing how we can navigate around Onshape, particularly focused at people who use SOLIDWORKS or Creo from PTC, and really people who are perhaps trying out Onshape during the professional trial, and they've come from those other systems, and you just want to try and give you a feel for how to find your way around Onshape and where perhaps the similar commands will be. Now, throughout this presentation, I want to try and make it as interactive as possible. So if you do have any questions, then please type them into the GoToWebinar question panel, and I will try to answer them as I go along. So I'm not going to cover everything because of obviously SolidWorks, Creo, and Onshape are very in-depth products, so there's a lot to cover if I was trying to cover everything. So I'm going to cover a lot of the basics. So I apologize if some of it is a little bit simple, but it's really just to give, a lot of times when we see people who are moving or trying out Onshape, is they get stuck on some of the basics. So this is trying to help you find your way around the system and also to answer any specific questions. So if you do have a question saying, how would I do this? Please type it into the question panel and I will endeavor to answer that during the presentation. Now, Onshape does provide self-paced online video training. If you go to learn.onshape.com, or there is a Learning Center button in the top right corner of Onshape, clicking that will take you to this website. Now, all you need to do is just sign in using your Onshape credentials, and there is a Fundamentals of CAD course. There's also a data management course, and all these will basically walk you through all the features available in Onshape, but they will make the assumption that you are already a CAD professional to a certain degree, and there won't be any equivalence between how you would do it in SolidWorks or how you would do it in Creo or CATIA or whatever else. So this is really what this webinar is aimed at. Excuse me. Okay, so both SolidWorks and Creo have a nice feature called the command finder. It might be called something different in both systems, but the idea being that if you the interfaces for both systems is quite complicated, Creo more so. So if you want to actually find the command, you can type in the text equivalent and it will locate it and also display it on the user interface when you click it. Now, the one on the right here is Creo. Now, this is not as clever as the SolidWorks equivalent, because in Creo, for example, a fillet is called a round. So if you type in fillet, if perhaps you come from SolidWorks and you go into Creo, if you type in fillet into here, or if you type in round, it will find it. If you type in fillet, it won't. So you can see it finds fill, and then as soon as you add more letters, it disappears. In contrast, on the SolidWorks side, they've added more links to more common terms used in different systems. So if you type in round into Onshape, even though the command is called fillet, it will find fillet, but it's also finding things like, we can see here, fillet is finding the fillet and fillet bead and sketch fillet. And then if you type in round, it's going to find circular pattern, fillet, revolve. So anything that somebody might consider to be round is included in there. So, it's a clever tool. Now, unfortunately, Onshape does not have an equivalent at this time. So this is, again, why this webinar will be helpful to many in finding that equivalent command when you're trying to use Onshape for the very first time. Okay, so let's just start with the real basics, and I will get more advanced as we go along. Now, when you start a new design in SolidWorks, you start a new document, you're offered three options: part, assembly, drawing. So these will show you these are the three basic options. Now, you can create your own start documents. For example, if you go to advanced, it will open up a new panel and it'll show you, for example, MBD got all these different templates you can select in order to do model-based definition in SolidWorks for different part sizes. And then it's a little bit more complicated when you come into Creo. So when you're creating a brand new file, essentially, then it's going to give you the option: are you creating a layout, a sketch, a part assembly? Are you doing manufacturings? Are you doing drawings? Are you doing solid? Are you doing sheet metal? So there is a bunch of items that you have to define up front in order to be able to define the geometry that you want to create. Now, Onshape is different in that it is not file-based. So whenever you do one of these operations in SOLIDWORKS or Creo, it's going to create a file on your disk. Okay, or it might be in session in the case of Creo, but essentially, eventually when you save it, it will be a file on disk. Now, the difference with Onshape is that because it's database driven, is that you can essentially enclose an entire project, parts, assemblies, drawings, plus whatever else inside one document. Okay, and let's just see how that works. So when you first create or when you first sign into Onshape, of course, this list will be empty because you wouldn't have created any documents. But essentially, each of these documents can have any number of parts, assemblies, and drawings in them. Now, when you create a new document, you're hitting this create button in the top left-hand corner. This will create a new, let's call it a new, we'll call it a project for argument's sake. Because, like I mentioned, when you first create it, we'll see that there is, first of all, there is something called a part studio, and there's also an assembly. But this little button in the bottom left-hand corner will allow you to create more parts, more assemblies, drawings. You can create folders to organize it. Then there's other different things up here. Feature Studio is for macro-like programming language, creating materials. And then you can add applications from our app store, things like machining, rendering, simulation, bill of materials, or MathCAD-like operations as an extra item within the Onshape document. So you can see there is a lot of things that you can do directly within this just one object. So you don't have to decide up front whether it's going to be sheet metal or whether it's going to be assembly or a drawing. You just create a new document, and then as you go, you just add more items to this document in order to fill out your project and complete it. Okay. Now, the next thing we'll do before we just jump straight into some actual feature creation is comparing the different ways of view manipulation. Now, at the top of the SOLIDWORKS display area, this toolbar has been there for some time. Creo copied it about Creo 3, I think, and did something very similar. And from here, you can do things like view normal, zoom to fit, zoom window, view previous, create a section view, different named views, view display, showing data and things, that kind of thing. And the equivalent sort of thing here in Creo. So there is named views, there's view orientation, or there's model display, and so on. Now, it's a little bit more hidden within Onshape. So when you do anything with Onshape with regards to manipulating the view on screen, then it's basically in this tiny little icon here. So in the top right, you'll find the view cube, which allows you to select individual standard views, as well as be able to rotate around normal to the screen or left and right, up and down. But this here, called the view menu, is where you'll find many of these items that you're used to seeing at the top of the screen, either in SOLIDWORKS or Creo. So there's a question here, can existing text material files be imported? With a little bit of manipulation, the answer is yes, because obviously the format in Onshape is slightly different to what you might find in SOLIDWORKS, for example. So yes, it can be done. And Stephen also commented that when I mentioned earlier about there isn't a command finder in Onshape, of course, you can use the Onshape help and search through that to find the item you're looking for as well. Thank you, Stephen. Okay, but before we go look at view manipulation as well, there's something else that is important to note. When in the top right-hand corner of your Onshape session, and it could be with an open document, or it could be from the documents page, which you can access from this image in the logo in the top left-hand corner. In your account settings, so you click your name and face in the top right corner, select my account. Okay. Under preferences, there is a number of things that you should consider setting before you embark on modeling. Now, you first of all will define whether you're going to use inches or millimeters. The default is inches, so if you're European or whatever, you might want to change that for millimeters. What this will do here is only modify new documents. Okay, so once you set this as a default, any new documents you created will be in those units. You can switch units inside a document if you change your mind later. But below there is the view manipulation. Now, in Onshape, manipulating things are slightly different from what you might be used to. So, for example, rotating the part, you use the right mouse button and drag. Constrain rotate, which is basically orbiting around a flat plane, is holding the Alt key and right mouse button. Pan is control or middle mouse button. So I tend to use the middle mouse button for pan. And zoom is basically the scroll wheel in and out, and then the equivalent 2D drawings. Now, in this little pull down menu here, you see we've got predefined setups for SOLIDWORKS. So that's going to be a middle mouse button for rotate, again, which you're used to. Alt and middle mouse button for constrain rotate, control and middle for drag, and scroll wheel or shift and middle mouse button for drag. So those are the options for SOLIDWORKS, and likewise for Creo, those are slightly different because they are shift and middle mouse for drag, for pan, sorry, and control. And yeah, that's the same actually for zoom as in SOLIDWORKS. So those are slightly different. So if you're using both systems at the same time, or if you literally just jump from one to the other, muscle memory is a terrible thing. You'll find yourself rotating the model when you meant to invoke the in context menu, so on. So it's worthwhile setting these settings. The other thing to consider as well is to turn off this reverse scroll wheel zoom direction. Or turn it on, I should say, because Onshape by default, when you zoom, will move the camera in and out, whereas both Creo and SOLIDWORKS move the object in and out. So again, it's the other way around. So whichever you feel more comfortable with, you might want to set these options here and then save those view manipulation settings. Okay, I won't in this case because I'm used to using Onshape now. Okay, a little bit further down there is a shortcut toolbar known as the S key in SOLIDWORKS, also known as the S key in Onshape. I'm not sure if there's an equivalent with Creo. My experience with Creo is probably latest is probably Creo 3, so I'm a little bit outdated there. So there might be something similar in Creo 5. I'm not sure. But the idea here is that you can predefine some of the most used command, for example, while you're in Sketch, and then pressing the S key on the keyboard will bring up this by your cursor. So it's just another way to customize the user interface. Okay, but we're not going to cover that in there. I'll just let you know that is there. Okay, so when you are in a document that has got geometry, when you're manipulating the view, you can see that there's no options here for view manipulation. They are all hidden here under the view menu. So you can see by default, the view is shaded with edges. If you prefer the Creo style shading, you can shade it without the edges, so it looks like so. And then you can show hidden edges or do hidden line removed or translucent. So there's all those different options there. What you'll also find under here is zoom to fit and zoom window and named views. So if you want to do more than just the standard views, which you would operate from the cube anyway, you can do those. You can do those named views from there. And it's important as well. Actually, named views are very good to do. So if you've got some kind of bizarre view that you want to look at, say this hole in this angle here, create a name view. I'll just call it view. And it just means that whenever you are in any kind of orientation, you can come back to the name views and restore it, and it's going to take you back to exactly where you were. That is also useful if you need to create a drawing view of something at a peculiar angle, because any name views you save in the model, you can use those to create a drawing view later on. So that's a tip worth knowing. The last thing I want to show on this menu is the section view. So turn the section view on here. There are hotkeys that will activate these. We'll talk about those later. And then it's basically going to ask you to select a planar face. That will generate a little arrow that you can drag. You can see that will then section the view. You can also see if you want to snap to something, you can pick this ball and you can see it'll snap to a center. So that's perfectly sectioned down the middle. And you can also use these little rotation arrows here and then type in a value or drag it increment wise to get the section that you want. And you can add multiple planes to section it in different ways. But these are some of the more common commands just from view manipulation that you might be looking for that you're used to seeing at the top of the screen. You can do that from the view menu. That view section will stay on, and if you click on the actual hatching, that arrow will appear and you can modify it again. You can also save a section in a named view as well, so if you're going to find yourself coming back to it more often, you can do that as well. And then if you need to switch it off, again, you can switch that view off. If you switch it back on again, it'll go back to where it was previously, so you can toggle it on and off. Okay, question there says, can I section only some of the parts? The answer is no, not at this time. The section view there is only it's only a graphical thing. Of course, if you want to do a section view in a drawing, you create a section view specifically. But if you want to show, just the case cutaway, then I'm afraid you have to just create a temporary cut. But there are little methods you can use for that, like configurations, for example, for suppressing a cut on and off if it's something that you need to display as a particular item in an isometric in the drawing, for example. Okay, let's jump back here. So we'll just start off with, we'll just do three main areas of comparing different ways you can sketch, comparing different ways we create features, and comparing different ways that we create assemblies. Now, if we take a look at a screen grab of the three toolbars for the three different products, you can see that there is a lot of the Creo one in the middle. There is probably the busiest. Both SolidWorks and Creo have gone for the Microsoft ribbon style interface, whereas the Onshape one is very simple icons. And when you hover over those icons, tooltips will appear. And I'm hoping that the icons are pretty much self-explanatory comparing to some of the other systems that you may be used to. Okay, and what you'll find as well is that certainly from a SolidWorks standpoint, is that how you create and modify sketches in Onshape is very similar. A little bit different in Creo. The idea really in a lot of the areas of Onshape is to try and give users all the power that you can get with Creo. I mean, I always say that, you can basically model with anything in Creo. It's just really difficult to use. Where get the power of Creo with the ease of use of SolidWorks would be the ultimate balance. Okay, someone's asking for an overview of large assemblies if there is time at the end. Okay, I'll make a note of that. All right, so creating sketches is pretty straightforward. Very similar to SolidWorks, you can either you can actually right-click a plane or something, select new sketch, or you can just select sketch and pick a face, or you can right-click on a face, select new sketch. Okay, so this is basically just defining the sketch plane. Now, what we're doing right now, and I'm going to come back to this in a moment, is we're building a brand new part inside something called a Part Studio. Now, Part Studio is unique in the CAD world, if you like, because it enables you to build related parts together, much in the way that you do like an in-context design in an assembly in, say, SolidWorks or Creo. But you're not making file references and references across files, which can be a little bit flaky when it comes to references updating and predictability, really, when you're making changes. So these are multiple parts built within one single part environment. So you can see there is a number of features, extrudes, fillets, chamfers, revolves, and all these are, in fact, let me just come out of that sketch for a moment, and all these have been defined perhaps from one single sketch, defining multiple individual parts, and those parts you can see here are appearing at the bottom here. So let's go ahead and create a new part, and we'll do that with a sketch. Now, very similar to both systems, you select a face or a plane to actually sketch on, And then while Creo really, although it does it a lot in the background these days, it does enforce you to select a horizontal reference so it knows which way is up. Onshape doesn't really do that. In fact, what you'll see is that it basically assumes a direction. So if you were to press N on the keyboard, which gives you a view normal, you can see actually I'm looking at this thing upside down. But if I was rotating it and then pressed N, you'll see it's just going to go to the very nearest orientation. That doesn't really matter. There are a few cases where it does matter, but in general, it's not really a concern. The only time it kind of bites you is if you've got it at perhaps 90 degrees and you're typing and you're putting in a horizontal constraint when actually it should be vertical. But one way to tell which way up your sketch is the actual text on the plane which appears. And that's not really a real plane. It's just a graphic to let you know which face you're sketching on and also the orientation of your sketch as well. Okay, so from a sketching standpoint, you have all the usual things. You have lines, rectangles, different types, circles of different types, ellipses, polygons, splines, points, text. Okay, you can also use existing geometry as well, or create intersection between the sketch face and another piece of geometry. There's also options there to construct fillets. You can trim, extend, and split, offset, create slots, mirrors, pattern, and insert DXF or images. Now, some of these operations are really not necessary. For example, doing trim is something I virtually never do, simply because of the way you sketch. SOLIDWORKS has had contour select for a while, and now Creo 5 has that capability. So there's a lot of similarity between the two. But if you've been brought up on Creo or Pro E, then I think you'll probably still get into the habit of trimming things, even though you don't really need to anymore. Okay, so what we'll do here is we're going to use an edge. I'll go to an isometric and make it easier to see what I'm doing here. Pick this edge here. Okay, so it turns black. It lets you know that it's fully constrained because it's selecting an edge. Now, this is one of the benefits of working in this multi-part part studio, is that I'm taking an edge off this plunger part, which means that, and in fact you can see if I hide that now, it's taking that edge, but it's allowing me to make sure that if the plunger were to change, then this what will end up being a hole will actually update as you would expect. Okay, and just for make it easy to see, let me just hide all those parts that we've created there. Okay, question there is, can you click on a face and hit N to go normal to it? The answer is yes. Again, the direction of the normal will go to the nearest normal. So you can rotate it using these little arrows here if it comes out of the wrong normal and you want to see it the other way around, for example. Okay, when you are sketching, what you'll find is that you create a circle, for example, and you get the option then you can see that there's a value there highlighted. You get the option there to actually type in a value. So just typing on the keyboard will enter that value, add the dimension, and turn it black. So the difference here, obviously, Creo will give you those dimensions automatically, and also make them, and then you can convert them to regular ones, or you can override them with existing dimensions. And SOLIDWORKS gives you that option if you've got it enabled. It's always on in Onshape. Whether you choose to enter a value or not, it's up to you. If you don't enter a value, then nothing will happen. So, for example, if I pick a circle over here and don't do anything, then that value is going to disappear. And very simply, just drawing on here, you can see it's picking up a constraint and a tangent. You can also then, pick up or highlight some of these other ones, so you can see I've made something horizontal to that and coincident to that and tangent over here. So very quickly you can start to draw and add these constraints. Now, if you want to add constraints afterwards, there's two ways you can do it. And in fact, let me just delete this constraint. If I hover over a sketch entity, whether it's a line or a point or a circle, then it will show you the the relative constraints that are set to that sketch. So if I want to get rid of that horizontal constraint, for example, just click it, it highlights, hit the delete key on the keyboard, and now that constraint is gone. Okay, and you can see there, then you get the whatever dynamic that you want to work on for your sketch, which is ideal, of course, if you're doing concept style sketches. Now, to add a constraint or add a dimension, there's two ways you can do it. You can either do it pre-select or post-select. If you do it pre-select, you can select two entities here and hit the tangent constraint button or press T on the keyboard. So you can see on that tooltip there, the keyboard shortcut is in the parenthesis at the end. Okay. Okay, someone's asking there, creating circles is so common, it would be nice to have a sketch belt style like SolidWorks belt command. Yes, we do have a belt command, but it's a custom feature, which I've got time at the end. I'll show you because some of these things are pretty cool. Now, if you hit tangent, of course, it's going to add that in there. Let me just, or if you do it post select, and I'm just going to undo that one just to demonstrate. That if you press the command first, then you can then it stays active. So you can click those two to make them tangent, click those two to make them tangent, and it will keep going until you disable that command, either by clicking on it or pressing the escape key to disable it. Now, you can see here from the different colors is that black means it's fully constrained. So if you try to drag this, then it's not going to move. However, anything that is blue is under constraint. So it's good practice, really, unless you really are at a concept stage. It's good practice to make sure that your sketches are fully defined in order that they're going to predictably update in the future. For the purpose of this for now, though, let me just go ahead and leave it as is. What I'm also going to do is show the plunger feature, or part, I should say, to demonstrate something, and I'm going to just talk about that in a moment. Okay, now when we're creating features, so I'm just about to create the first extrude. Again, looking at the three user interfaces, this is the one for SolidWorks, which is solid. They have a separate one for surface. They have a separate one for sheet metal. They have a separate one for weldments. Creo, same sort of thing. They have one for modeling, although they have, Creo, the way it works is it's a lot more compact, and it works very much like Onshape does. So, for example, if you are creating some of the basic building blocks for a solid model, extrude, revolve, sweep, or loft, for example, SolidWorks has this crazy way of working where you would have an extruded boss, an extruded cut, an extruded surface. And when you click on, although this user interface will be slightly different for those three options, you're essentially doing the same command, but located from three different places, which is kind of a little bit crazy. Now, Creo's got it better because you are generically extruding, and then it gives you the option to be solid or surface, or if it's a cut, it gives you the cut option, or you can thicken it in here. And so from one feature, we'll give you all the different types of features, whether it's an extrude and a cut or a surface. The way I like to say it's both Onshape and Creo. The extrude is a verb, if you like. It's the act of extruding, whereas these are more nouns, if you like. The finished object is an extruded cut boss, an extruded cut, or an extruded surface. It just seems like icon overload for no particular reason. So it'll be a little bit more familiar to Creo users how it's done in Onshape. So, for example, here now, if I go ahead and hit the extrude button, okay, you'll see that even though I didn't trim the sketch back, it worked out the individual internal contours and therefore created a hole here. Let me just make that full. So you created a hole here and not over here. And you also get a little drag handle to actually change the size, which is fine. But in the same way that we have in Creo, you can build every single type of feature from one extrude command. So we have solids, we have surface, Now, the reason that's disappeared is because Surface is expecting you to select individual entities. So, you might want to select those two, but essentially you're creating a surface from the same extrude command. Then you have solid, you can create new, you can add, you can remove, or you can intersect. So the intersect is like a Boolean intersect. Now, at the moment, some of these aren't working as you would expect. They're giving, so when I do add, for example, it's now adding any geometry I've created to any parts that it intersects. In this case, the plunger. Okay, so it's like we're adding geometry to that plunger. Alternatively, I could remove that, and let me just flip the direction, in which case nothing's going to happen because I've got a hole here. So in fact, it's telling me here that they do not intersect. And likewise with the intersect, they also don't intersect because, again, I've got that hole in there, which I probably shouldn't have put in there in the first place, but let's not worry about that. So what I want to point out specifically is this button here called New. Now, when you add New, you'll see that a new part appears in the list at the moment that you do it. So this is creating a brand new part within this part studio. And this is probably what you're going to be doing a lot of the time in order to build new parts together. Now, from a perhaps a usability and even maybe a performance standpoint, I wouldn't suggest building an entire assembly, 1,000-part assembly in a part studio, simply because the number of features to do that will soon like snowball and get a little bit out of control. So really only model parts together if they are related. If they're completely unrelated parts, or they might be part of the same assembly but they don't actually physically touch each other, then consider creating multiple part studios. It'll just make the whole thing a little bit more efficient and a little bit more easier to navigate. Okay, so from this one command here, the one extrude command, we've then created a brand new part, and that's called part 4. Now, the fact that this sketch is here, we can reuse that sketch and build any number of parts out of it. You can also do things like, we can create chamfers over multiple edges. So, for example, there I've selected the top of the plunger, and also you can pick the edge of extrude and build a chamfer on two different parts at the same time. Okay, if you wanted to do that. So the fact that it's multi-part as opposed to multi-body in SolidWorks, you can do things like add chamfers and parts across multiple parts, and a lot easier to control. So yeah, someone's mentioning there, parts on Onshape are equivalent to bodies in SolidWorks. From a basic standpoint, yes, but the difference is that in SolidWorks, if you wanted to use those bodies in different assemblies, for example, you would have to save them out as bodies individually, and then have an extra file which controls those parts. These are parts in their own right. So this part 4 can be used in 10,000 different assemblies, but still be generated from this part studio. So that's probably one of the main differences. And the fact that they can all have different materials, properties, and whatever else, you can do that as well. Okay, let's just go back in and edit that sketch real quick, and let's just add a couple of dimensions. So adding dimensions, as you expect, there's just one command, and it's whichever geometry you select and wherever you place it, so it's going to make a lot of sense. So just give that a size and make that 1 inch, and we'll just add another circle in here and make that 0.5. Okay, now the fact that I've added another contour in here, when I click OK on that, it's going to add the hole in. If that is not correct, you can edit the actual extrude feature by double clicking, and just by clicking the area, you can include that in the sketch if you wish. So when typically you want to lay out multiple contours, you don't need to bother trimming, just sketch it, everything that you need to see. So it could be a layout for a mechanism, for example. Just need to sketch what you need to create, and then just choose the areas which make up the individual bodies, and that will generate the shape for you. You can also do things like, let's just add a fillet on there, for example. Let me just make that a little bit smaller. Okay, and just things like if you're adding draft. I know they introduced this recently in Creo 5. So if you're using Creo 5, then you're going to be used to this. But sort of thing you can't do in SolidWorks is if you're creating a draft on here and you want to draft all these edges, you can see that it doesn't matter that the draft came after the fillet. It's still being generated after the fact. So the whereas a lot of solid modeling courses you're taught to add your fillets and your chamfers right at the end. You can do it, and in particular, do your draft first and your fillets second. You're a little bit more flexible here in Onshape. Okay, so that's the basic shape. One other nice feature I think it's worth showing, if you wanted to modify perhaps the size of this thing, you do have the view manipulator in there, so you can modify it. But of course, editing an older feature means that any of the future features are suppressed while you're editing it, so you can't see what the effect of that is. This, I think, is rather cool button. This final button here will actually rebuild all the other features after it and give you a dynamic update. Well, in fact, it's not going to change much because of the direction of the draft, but you see what I mean. So it's actually showing you the draft and the fillets on there as you drag that the size of that geometry. So again, it's a very, very powerful piece of capability. And the reason we're able to do a lot of these things is because it's in the cloud. Because we're running multiple Onshape servers, we can multitask a lot of the things like rebuilding the feature tree, or even if when the model's rebuilding, you won't see it on this because it rebuilds too quick, but I could actually start a new sketch while the model was rebuilding and pick a new face because it's multitasking in a lot of senses. Okay, let's jump back over to here, and we'll take a look at assemblies. Now, both in SolidWorks and Creo, you can pretty much do anything with assemblies. The variety of options in SolidWorks can be a little bit bewildering. So you have your standard mates, then you have your mechanical mates, which is your gears and your rack and pinions. Then you have some advanced mates to do something that you might not do quite as often. And typically it would require you to have 2 or 3 mates to physically constrain a part relative to something else. And I like to think of it as in SolidWorks, you're removing degrees of freedom. Okay. In Creo, you have a bit of both. So you have joints here, which I should have had shown that pulled down. Joints, which is how Onshape works, and you also have regular mates, which is how SolidWorks works. So Creo's probably got the best of both worlds, but you still have to generate a certain number of pick placements in order to constrain 2 or more parts together. So let's take a look how it works in Onshape, which is something which takes a little bit getting used to, which is why I want to spend a little bit more time on this if you are used to mating items in the I'm going to call it the old way then, but how SolidWorks and Creo. So let's build a new assembly. So we're going to hit the plus button in the bottom left hand corner, create a new assembly. So it's going to be a blank screen. And then you can see there's an insert button. So this is going to insert either items from your current document. You can insert items from other documents. Okay, so you've got whatever documents there. There's also a standard content option here. So if you need to do nuts, bolts, screws, and washers, you can insert them from here. So that's included as standard. You don't have to have SolidWorks Toolbox or whatever the Creo equivalent is. You get those capabilities there. Now, here we see the hydraulic clamp part studio that I created previously. Now, this is basically just a collection of parts. They might all be driven from the same sketch or the same layout. However, you can individually assemble parts from multiple different part studios to build an assembly. And this is what I mentioned earlier about having they are parts in their own rights rather than just a a part file which has got multiple bodies in it, which you would get with SolidWorks. Okay, let me just undo that. However, you can treat a part studio almost like a subassembly by clicking the actual name, and it will bring all the parts from that part studio into the assembly. Now the question is, you can place that, or you can just press the tick, the green tick, and it'll position it relative to where it was in the part studio, which in this case it's around this origin here. Now notice here that all these parts are completely unconstrained relative to each other, mainly because, like I mentioned already, parts, they're individual items in their own right, and there's, when you get out of the part studio environment, there is no relationship between them. So in order to get this moving, and this is one of the reasons, you create an assembly to look at motion, to create an accurate bill of materials, but sometimes there's no need to actually create an assembly. You can just create the data in a part studio. Okay, but what we'll do here is we'll take this part, I should say, right click and fix it. Okay, now the fix command, this is something which some people get confused about, and it's peculiar to Onshape, is that the fix command only works in the context of the assembly that we're looking in right now. So what happens if I go to this this other assembly, and in fact, let me just make it a little bit clearer. Let me fix this O-ring as well. So I'll right click this and fix. So at the moment, if I try to move those in this assembly, you'll see they don't move. If I go to this other assembly and insert the assembly I've just created, okay, let's just go and place that there, then you'll see that these still move. And this is where some people get confused, because the fix command only works relative to the assembly that you're in. If you want those two to stay relative to each other, then what you do is take one or more items and use this group to add them together. So it groups them together, and it means that they will then move as one item. Okay, so then if I go back to this main assembly, you can see they are now grouped together and they move together as one item. So please don't get confused. Fix is only for the assembly that you're in. If you want to keep them together, use group. Once you have Don Van Zyl saying it's like having a bunch of loose parts on a workbench ready for assembly. You're absolutely right, Don. That's exactly what it is. So laying out all your parts that you want to assemble on the workbench, and then add them together. Now, the way we assemble parts together in Onshape is by using these bunch of mates here. So there are 7 different mate types: fastened, revolute, slider, planar, cylindrical, pin slot, and ball. Okay, you're probably not going to use those very often. There's also some extra ones for parallel and tangent, which is more for like simulating cams or making sure a robot gripper, for example, stays parallel to the floor, something like that. So you want to add those 2 constraints in those instances. But in general, the first 3 and cylindrical are probably the ones you're going to use the most. It's quite easy to spot a new SolidWorks user coming from SolidWorks to Onshape, because the mate list is full of planar mates, because people are trying to add 3 lots of planar mates to constrain something together, but there's no need to do that. Question there: can mates be made to the origin or the axis of the assembly? Absolutely. We'll take a look at that in a moment. But essentially, if you want to fasten 2 parts together, you click the fasten mate, and as you hover over geometry, you'll see that this little symbol appears, and this thing is called a mate connector. And think of it like a coordinate system, whereas the red, green, and blue is X, Y, and Z, and obviously the orientation of this particular thing is pointing up. So you say, okay, I want to connect this coordinate system. Well, it's mate connector really. And then as you hover over any other geometry, you can see that these appear. Now, these will appear at the center, the centroid of a face, the center of a circle, a vertex, middle of an edge, and these will appear here. So you don't have to create these up front. There is a special mate connector button there if for some reason you need to construct a make connector in a certain position, but they are created on the fly. So simply go to the make command and pick fastened, and then click the 2. Notice that the plunger jumped from the left over to the right. It's generally, that's just the order that they were selected in is how they're solved immediately. However, the order is not necessary, doesn't matter basically, but it's only from, it might confuse you if you see a part jumping from one side to the other. Okay, so you're basically assembling this to that. And if you think about it that way, that makes sense. Now, if you, what you'll see now is that these will now move together as one. You can see there is a fastened mate appearing in there. Now, if you want to do something like an offset, there's 2 ways you can do that. You can either, while you were creating the actual mate itself, there is an offset button there, and these X, Y, and Z coordinates are relative to the mate connector. So if you want to offset it, so minus 1/4 inch, or in fact plus 1/4 inch. If you want to offset it a certain amount, then you can type that in. And obviously, if you start doing something like that, it will actually put it in an offset location. But again, it's easier to do that if you are restricted in the location where you can place a mate connector. Okay. The other things you can do here is you can flip it the opposite way around. You can also clock it around 90 degrees as well. The actual plunger is rotating there, which is why you can't see it moving, but you can see the mate connectors moving relative to each other. Another way to do it is if you expand a mate, you can see that it will actually show you the mate connectors relative to that were used to actually generate this mate. So you can see the one that belongs to the plunger and the one that belongs to the mate connector. So if you wanted to actually put an offset in there, you can realign it to existing geometry. So, you could pick an edge over here. Oops, sorry, that should be the secondary axis. And you get it to realign, or you can move it in the XYZ or change the rotation angle. So there's a bunch of things you can do to modify a mate to get it to work how you want it to do. Off-topic question here, but is there an offline version of Onshape? No, there is not, because we can see here that we're working in a web browser. All the Onshape servers are on Amazon Web Services, so there is no local install for the data. Yes, there's the problem with internet connection at times. There is obviously there is a mobile app as well for Onshape, so you can run it on a phone or a tablet if you have 3G or 4G connection. But again, if you've got no internet connection, then I'm afraid you're out of luck. So in those instances, it might not be the best solution, and that stance will not change either. There will never be an offline version of Onshape, and it's simply just because of the architecture that we built. Okay, and then finally, let me just do one more here, and I'll do a section view. So we saw section views there before, just so it can easier to see what's going on. And I'm going to do a cylindrical mate. So this, again, we are adding degrees of freedom rather than removing them. So this is going to be perhaps the mate connector over the bottom of that face and the mate connector there. We'll position these two together. And if you press the play button, you can see this thing going up and down. You can also add limits in there to stop it going a certain height if you wish, but that's then going to give you both translation and rotation. Okay, so you can see here we've got a group and two mates. Whereas if you do that in SolidWorks at least, then you probably you've got an insert and a mate, an insert and a mate, and at least four or five mates as opposed to 2 that you would have in Onshape. So once things start to get more complex, you get in larger, more complex assemblies, then you'll see that your mate features list will be considerably smaller than you might be used to seeing in SolidWorks or indeed Creo. Okay, and then as we go back to that master assembly, you'll see, of course, that is updated. there is no such thing as a flexible assembly in Onshape. Basically, everything is flexible. So it just means that you can have this assembly here, for example, and we'll mate that to here, for example. And now because I didn't put any limits on that, you can see that things come out. But let me just pull it down to approximately there and spin it up to the top. And it just means that you don't have to worry about making all your sub-assemblies flexible, because then you can do things like take this assembly here and use the replicate command to find all the similar holes in that edge, and then you've got the then of course, because it's flexible, each individual sub-assembly can be in its own position and own orientation. So there is no need to worry about modifying a bunch of assemblies. In fact, you can see those a bit high up. Not to worry. Again, I should have put some limits on. Let's just box select those guys and just move them. Oops. Just move those down. Okay, and of course I could have added a mate to the underside of that plunger and that flat face as well. So there is a bunch of ways you can create a hierarchy of sub-assemblies and have them flexible by default and be able to get the exact thing that you need within your design. Okay, some of the more advanced topics might be things like configurations in SolidWorks or family tables in Creo. These are actually highlighted over here. So the configuration panel will basically allow you to configure any part within a part studio, and because you can have multiple parts in a part studio, you can configure them all together. So if you think you're defining this part, you could change the plunger size and the size of this thing as well, and it's reasonably straightforward. You could create one called short, one called long, and then configure the features that you want to set. So if you want to configure, not that one, this sketch here, and we'll just configure that dimension, and that's going to be 2.5 or something like that. And it means that then just doing that simple operation there, you get a separate menus here, which you can then define these as short or long. When you go into the assembly, you can see that this even though only this part is configured, it's the only thing we configured, you can see that all of these have icons on them that claim they are configurable, because the configuration is driving the entire part studio. But essentially here, all we're going to do is right click and change configuration, and we're going to set that to long, and that's going to in this case, because it's just using the same assembly, it's going to appear in all those instances of that top assembly. Final thing I want to say about features is sheet metal. Whereas in Creo you must create a sheet metal part file, and in SolidWorks you must create a single sheet metal part per part file. Yes, I know you can have multi-body sheet metal parts, but again, the ultimate goal is to join them all back together. Essentially, sheet metal can be accessed from all these sheet metal options here. The difference here, and let me just do a real quick example, and I'll just sketch 2 lines, something simple like that. If you're doing sheet metal, then you have the option to convert a solid to sheet metal, very similar to the way you can in SolidWorks. You can extrude, you can thicken a surface, or you can extrude 2 edges. So likewise, you might want to make this thing symmetric and drag it. You can see it's already put the fillet in. The difference here, and really, there's a full webinar's worth of content for sheet metal, is that once you create a sheet metal part, and you can create as many as you want in the same part studio, there is an extra tab appears here, which basically gives you the flat view of the model. So you don't have to flatten it to see if it's a viable sheet metal model. You can see it directly here. You can modify the radius from the table view here. You can sketch in this view to add features in here, or you can sketch on here, and as soon as I use an edge off here, and remove it. And so, okay, so this one here, merge scope, it's worth actually noticing because that feature there intersects multiple parts. It's basically asking which ones you want to intersect. Okay, so it's actually the sheet metal part, and as soon as I do that, you'll see that hole will appear there. So you've got the be able to see the full sheet metal design as you are, and flattened design as you're modeling it. Okay, question here: how do you position plunger head precisely? On something like this, on this master cylinder assembly, you can actually take well, the orientation of this is relative to the sub-assembly. So in order to control the position of that, you would have to add another mate at this top level in order to control that. You can, if you have it in one orientation, you can, if you wanted to get it roughly right, it's 15 degrees from where it was, you can use those manipulators. But if you want to make that parallel to this face over here, for example, then you could say, let's make that parallel with this guy here. Oops. It's obviously of course it's contradicting it. Yeah, so overpowering that, and in fact, it's quite right because of course that's got draft on it. So it's actually telling me there that it can't actually do that. Okay, I thought something was wrong then, but no, it's absolutely correct. It can't be done. All right. Okay, last thing I want to mention about the differences between SOLIDWORKS and Creo is when it comes to sharing data, because those systems are file-based driven. If you wanted to share an assembly with somebody else, you can use SOLIDWORKS Pack and Go, or in Creo, you've got the mail option, which will attach a zip file to an email. Not only, you'd have to email SOLIDWORKS files, so not only is that not secure, it's also makes a large amount of data and makes it difficult, with email size attachments. Once a file's emailed, you don't know where it's gone, that kind of thing. In Onshape, it's completely different. If you just need to share data with somebody, all you need to do is just hit the share button in the top right-hand corner, and you can type in somebody's email. So Michael in this case here, and specify whether they can edit or view, comment, share, export, or copy. And this is very similar to Google Docs. If you've ever used Google Docs, then you know that you're never actually moving a file from one location to another. You're simply inviting somebody in to be able to edit that or view it. It works exactly the same in Onshape. And it just means that, if you need to work with the rest of your team, you can add whatever team in there and share it with them with edit permissions, or the entire company. If you're on the free version of Onshape, all your documents will be public. If you're not, then you can make a document public. For example, if you are a motor supplier and you want people to be able to see that, you can make it public. And the final one there is link. Now, a link is interesting because a link is view only, and nobody can actually edit it or copy it. So it's ideal if you just want somebody to take a look at something. Email them the URL. So if you make a link viewable, copy that to clipboard, you can send them that URL, and they will literally open within another browser window. In fact, let me just do that. Just go ahead and open Firefox here, for example. Copy and paste that in there. Okay, and if that person doesn't have an Onshape account, you'll see that it just opens in the browser anyway, so they don't need to download or install eDrawings or Model View or anything like that. You can get that capability directly in there. If they have an account, they can sign in, but you can see that they can take measurements, and they can hide parts and that kind of thing. If it's great for suppliers to be able to do a RFQ or something like that without actually needing access to the model, or indeed access to Onshape. Okay, I know we're running out of time here, and I have pretty much finished up here, even though I did skip a few things. Last thing I want to mention here is keyboard shortcuts. If you want to become a master in Onshape, certainly keyboard shortcuts is the way to go. Now, the only difference, because now in Creo 5 you can create your own keyboard shortcuts on top of map keys. Map keys are cool if you can remember what they all are. For anybody who doesn't know, Creo is basically you can specify it's almost like a macro, if you like, and run that from a single key. And in SolidWorks, you can define your own keyboard shortcuts as well. So the keyboard shortcuts in Onshape are fixed at this point. There has been lots of requests to have them customizable. But if you click on the help menu, go to keyboard shortcuts, it'll list all the individual shortcuts for general, part studios, sketches, drawings, and assemblies. Okay, so those are all the keyboard shortcuts. And something that you might want to do for Onshape is to learn these, or at least learn the most common keyboard shortcuts. And at some point in the future, we'll give the option to be able to customize those. The other thing to remember, of course, is the S key, which I mentioned earlier. Pressing the S key is totally customizable. So in many cases, you'll be able to circumvent keyboard shortcuts by using the S key. Quick question there is give a quick licensing overview for Onshape. If you go to onshape.com, go to the pricing webpage, there's basically, we list the three main items here, which are Onshape Standard, which is $1,500 per user per year. The Professional, which is the most popular at $2,100. The main differences between these are is a release management. So in both products have data management included. So when we look in here, we can create versions. So we can come in here and create a version, and also be able to manage all the data in one document. Well, the difference is between Professional, it gives you release management, so it gives you a proper release workflow. So, for example, if we're in here, instead of doing a version, we can do a release. Okay, it says I'm not a member of a company, so I can't anyway. That's fine. Because I was running Onshape Standard, so it wouldn't let me. So it gives you release management, and it also gives you things like custom properties and consolidated billing and company level operations. If you're a student, there is the education plan, which is the same as Onshape Standard, but it is free for students. And the free plan is also available, which is for free. Now, Enterprise, that is something completely different. That includes things like analytics and activity tracking, and which is great for perhaps larger organizations who need to have more of an insight into the design process. Enterprise is a great product. Point there made by Stephen is the big difference in OS versioning is done at dot level versus element level. That is true. When you create a version, so if I go ahead and create a version 3 here, it versions everything within that document at that version. And really what a version is in Onshape, if we take a look at here, before version 3, which I just created, these are all the operations that I did during this webinar. Okay, so I can jump backwards and forwards. It basically gives me unlimited undo and redo right back to when this thing was first created back in February. So I can jump backwards and forwards. A version is essentially just a bookmark or a point in time. If you wanted to do release management, then from the Professional, then you can release. Although it's saying I'm not able to in this case. Well, in this case, that is per element or per part rather than for the entire document. So, question about the free version gives you certain functions, and the paid version gives you other functions. Yes and no. The only differences are in the Professional version, you get release management and you get extra capabilities in Enterprise. The only difference between Standard and the free version is that free version, all your documents are public. So it's about open source. So you're basically paying for privacy, but the capability of both systems is identical. Okay, I do realize we have overrun here, and to be honest, I thought we'd run short in this webinar, but we've covered quite a lot. I hope it's been useful. I know some of it's been a bit basic, perhaps for some more advanced users, but if you're coming from those other systems, it can be quite a bit daunting. Well, it's daunting to learn any new software for the first time, but hopefully this has helped you do a little bit more of a transition and get a little bit better understanding of mapping one product to another, and also to take a look at some of the unique capabilities of Onshape. If you need to get hold of me, if some questions pop up later, my contact details are there on the screen, both email, Twitter, or from the forum. The forum is the best place to post any technical questions, because not only is it manned by staff, it's also manned by some of our power users and, well, anybody in the Onshape community who are very willing to help answer. So if you've got a problem, post a link to your public document and somebody will help you out. Okay, one more question here. Can inherent planes and axes of parts and assemblies be used to create mates? There are no planes in assemblies. There is, you can create mate connectors at the origin and use that. That is one method. So therefore, you can create a mate to the origin and use these offsets that I showed. You can also, if there's a specific mating location on a part, in the part studio, you can create a mate connector and attach it to that point. So that means when it comes to the assembly, you've got a fixed location to assemble to. So so there are no planes or axes in the assembly, but you can, if there is no geometry which supports assembling to that, you can create a mate connector at the part level in order to drive those locations. Okay, all right. Well, I'm going to wrap up the webinar there. I'm going to stay on for another 10 minutes. So if any more questions, please type them in. If not later, use my email address as shown below. From that point, I'd like to say thank you very much and have a great day.